Now let's take a look at the second problem. So a pebble, it dropped it into a calm pond and causing ripples in the form of concentric circles. So it's look like this. So when you have a pebble drop and it's make a concentric circle, the radius of the outer ripple is increasing at the constant rate of 1 foot per second. Okay, so the radius of this is changing, right? It keep changing. So the radius change, so we call that is R, the radius R. And then increasing, so you're gonna have the rate gonna be positive. So the derivative of R with respect to time is 1 foot per second. Okay, and then when the radius is 4, what is the rate of the area of water distributed changing? Okay, so it means when the radius change, what is the area of the water change, which is the circle? Okay, the area of the circle change. Area of the circle changing at the radius is 4. So derivative of the area with respect to time when the radius is 4 is equal to how much? Okay, so in this case, because our water is actually make a concentric circle, so and the area of the circle is what? We're gonna have to go back to our formula. Yes, the area of the circle is pi r squared. So we're gonna write that area, the formula down. So the related equation will be pi r squared. Okay, and then we're gonna take the rate of change of the area, which is d over dt of the area and d over dt of pi r squared. Okay, so the rate of change of the area, same thing with respect to time, we're gonna have a chain rule. The derivative of A is 1 times dA over dt equal the derivative of, this is the coefficient. When you have a coefficient in your derivative, the coefficients stay the same, and you take the derivative r, you gotta bring down the power, and then 2r. And don't forget you have dr over dt. You have the chain rule. So in this section, all the variable that you take with respect to time will have the chain rule. You have to multiply dr over dt. Just like you take implicit differential equation, you have dy over dx. Must be adding when you take the derivative with respect to y. So let me go back to that one. What is the implicit? Okay, right here. The reason why I have to take the derivative of y squared, I do either 2y times y prime, because y is the function in terms of x, and the variable that you take is with respect to x. So that's why anything that not the same variable, you're gonna have to do the chain rule. Okay, so for example, if you do dx over d of dx of h, okay, and h is the function of x, which is not constant, then you're gonna have 1 times dx over dx. Okay, so this is gonna be the chain rule. So now let's go back to 4.1. So we have and we find the rate of change of the area, and we're just putting everything we have. So I have pi times 2, the radius is 4, the rate of change of the radius is 1. So the answer will be 8 pi feet per second. Okay, so when the radius is 4, the area is changing about 8 pi, increasing about 8 pi feet per second.